Hello Year 8, let's go through your answers to the 5 a day. So the first one, we're multiplying decimals. Rather than multiplying decimals, we prefer to multiply fractions. So we'll rewrite our decimals as fractions. I'm going to then multiply the numerators, multiply the denominators. 8 times 37, I'm not going to trust myself to do that in my head. I'm just going to work it out at the side here. 8 times 7, 8 times 3, plus the 5. So we've got 296 over 1,000. We rewrite it as a decimal, so that's 0.296. Here, so we're using order of operations. So I'm going to do the brackets first. So I've got 2 to the power of 3 is 8, plus 2 is 10. Then I'm going to deal with the indices. So I've got 2 to the power of 3 and 2 to the power of 3 here. So remember, there's an invisible multiplication sign in between the 2 cubed and the 10. 2 cubed is 8 times 10 divided by 2 minus 8. And then multiplication and division are equivalent, they're on the same level, so I just read from left to right. Okay, 168 is a product of its prime factors. So let's start with the smallest prime number, that's 2. That works because this is even. 2 works with 84 as well, and with 42. 2 isn't a factor of 21. 3 is the next prime number, that is a factor of 21. 21 divided by 3 gives me 7. I haven't written it as a product yet, so finally I need to write 168 equals 2 cubed times 3 times 7. The highest common factor of 14 and 35, I can just think about my factors of 14 are 1, 2, 7 and 14. My factors of 35 are 1, 5, 7 and 35. So the highest common factor is 7. And to find the area of a triangle, I'm going to do the base multiplied by the perpendicular height and then divide it by 2. My lengths are measured in centimetres, so my area is in centimetres squared. So today we're going to be looking at collecting like terms and solving equations. So we're going to look at solving equations that involves collecting like terms. But before we do that, we'll just have a refresher of what like terms are. So in this column here, these are all examples of like terms. AB and AB, they've got the same letters, the same pronumerals with the same exponents. Same pronumeral, same exponent. Same pronumeral, same exponent. It doesn't matter that one's BA and one's AB because we know that multiplication is commutative, and so BA is the same as AB. In this column here, we've got non-examples. So these terms all contain different letters. So do these ones here. Here we've got the same letter A, but different exponents. This is A to the power of an invisible 1, and this is 2. Different exponents means they're not like terms. So this is what we were just discussing. Let's have a look at these. Pause the video and decide whether you think yes or no for whether each of these pairs are like terms. Okay, hopefully this is what you decided. These both have an x, so that's fine. These both have an x, but this is an x squared and this is x to the power of 1, so these are not like terms. These are both x squared y. These are both a, b. These are both mn, but in the first one it's the n that's squared, in the second one it's the m that's squared, so these are not like terms. Okay then, so how are we going to collect like terms in this equation? I need to have all of the x's on the same side of the equal sign to be able to collect them. Now I could either do that by subtracting 2x from both sides, or I could do it by subtracting 5x from both sides. I'm going to choose subtract 2x because that's smaller. 2 is smaller than 5, which means that I will end up with a positive number of x's, a positive coefficient of x. So 5x minus 1 minus 2x, that gives me 3x. Now this is an equation like last lesson that we're used to, so I'm going to add 1. That's the section of my screen that doesn't work properly, so let's move it down slightly. Sorry, it's 4. And then divide by 3. And 4 divided by 3, that doesn't give me an exact decimal or a whole number, so I'm just going to leave it as a fraction like this. Pause the video while you have a go at this example. So here I've got 3x and 1x. 1x is a smaller number of x's than 3x, so I'm going to start by subtracting that from each side. Be careful, this is a negative one, so make sure we keep it negative. This is one like you're used to, so now I just subtract 3. Be careful here, negative 1 subtract 3 gives me negative 4. Divide by 2. Remember, you can substitute in. I could have substituted in here. It makes it a bit trickier when it's a fraction, but you can still do it. But this one's relatively simple. So let's check. Negative 2. 3 times negative 2 is negative 6. Plus 3 gives me negative 3. Again, negative 2 subtract 1. That gives me negative 3. My two sides are equal, which is what I was after, so I know I've got it correct. Okay, pause the video now while you have a go at question 5 from your textbook. So in this example, you can see that we've got 2 brackets on one side of our equation. What we're going to have to do here is expand those brackets and then collect like terms and then solve. So you'll remember from our solving equations with brackets lessons, when we multiply out brackets, we multiply everything inside the bracket by the thing on the outside. Now here, notice this is minus 4, so I've got minus 4x, then minus 4 times 6. Now I'm going to collect like terms. I've got 6x and minus 4x. I've got negative 10, negative 24. Now this is just a straightforward equation that we know how to solve. So we add 34 to each side. And then divide by 2. 41's not even, so I can just leave it as 41 over 2. Pause the video while you have a go at this one. So let's start by expanding. Collecting like terms, 6x plus 2x, negative 12 minus 2, really, I should be lining up for my equals sign. Add 14 to both sides. And divide by 8. And again, just leave it as a fraction. Pause the video now while you have a go at question 6. In this last example, you can see that we have the pronumeral on both sides of the equal sign and we've got brackets. So let's have a look at how we deal with this. I'm going to start by expanding the brackets, and that's what you should do every single time. It's almost never going to be the case that dividing by the number on the outside of the bracket will make it easier. So we start by expanding. Now, this is like the first example that I went through. So I've got 15x on the left-hand side, 6x on the right-hand side. 6x is smaller than 15x, so I'm going to subtract 6x from both sides. Then this is one that I am familiar with. We've been doing lots of these, so I add 10 to both sides. And divide by 9. Now let me just show you, if I had have subtracted 15x from both sides instead, so you see I get the same answer. Remember that when we divide a negative by a negative, the answer is positive. It's just there's a lot more negative numbers flying around, and that gives me more opportunities to make mistakes. And if I want to minimize the mistakes I make, then I want to stick with positive numbers. Okay, pause the video while you have a go at this one. So we don't like having the brackets there, so we start by expanding. I've got 5x and 2x, so I'm going to choose to subtract 2x from both sides. This is a negative 4. Make sure we know that. Then subtract 15 from both sides. Then divide by 3. And that's it. That's a rubbish x. Sorry. Even more rubbish now. Okay, so these are your last questions for this lesson. Make sure you're showing each of your steps, step by step, step by step, step by step. And let me know if you have any questions. Thank you very much.